You're looking at the biggest plot twist in medical history. A virus that terrified the world, and a cure that wasn't found in a lab. It was hiding in our own DNA. The cure was already inside us.
For decades, HIV was a death sentence, an incurable plague. But what if I told you the secret to defeating it wasn't cooked up in some high-tech lab? What if it was hiding inside us all along, in our very own DNA? So how do you cure an incurable disease? How do you fight something that literally becomes a part of you? And get this, what if the key wasn't some new miracle drug, but a simple mistake, a glitch in our genetic code? Okay, so before we can get to the cure, you gotta understand the crime. We need to look at the enemy's blueprint, right? See exactly how HIV pulls off its heist and breaks into our cells. It all comes down to this one idea. A doorway. I want you to picture your immune cells like these little fortresses. HIV, it's smart. It doesn't just try to blast its way in. No, it needs a key for a very specific door. And that door is a protein on the surface of your cells called CCR5. And the way it works is just brutally simple. The virus floats around, finds one of your key immune cells, and it just latches right onto that CCR5 doorway. It turns the knob, walks in, and that's it. It's inside. And once it's in, that cell is no longer yours. It's a hostile takeover. That cell is now a factory, pumping out more and more copies of the virus. But, and this is where the story gets really interesting, nature threw a curveball. In all its randomness, evolution accidentally built the perfect defense, a shield that no one could have designed on purpose. And I mean this literally. There are some people walking around on this planet right now who are basically immune to HIV. The virus just can't get to them. It's like it hits a brick wall. So the billion-dollar question is, how is that even possible? Well, the answer is this tiny little fluke of genetics. It's a mutation called CCR5 delta 32. All it means is that the instruction manual, the gene for building that CCR5 doorway, has a page ripped out. And because of that missing piece, the cell can't build the door properly. It makes a broken, useless version that just gets thrown away. This right here shows you everything you need to know. On one side, you've got a normal cell. See that? The door is wide open. It's basically got a welcome mat out for HIV. But on the other side, that's the cell with the mutation. There's no door. It's gone. It's just a smooth, solid wall. The virus can bang on it all it wants, but there's no way in. Period. Now, how you get this is what really matters. If you inherit one copy of this gene, say from your mom, you get some protection. It helps. But if you hit the absolute genetic jackpot and get a copy from both your mom and your dad, well, now we're talking. Your body just doesn't build any of these doorways at all. You are, for all intents and purposes, HIV-proof. For the longest time, this was just a cool biological fact, you know? A fun piece of trivia for scientists. But that all changed when one doctor, faced with a patient who was dying from 2 different diseases, came up with a plan so crazy, so ambitious, it just might work. Let me introduce you to Timothy Ray Brown. History knows him as the Berlin patient. He'd been living with HIV for over a decade. But then things got worse, a lot worse. He was diagnosed with a really aggressive leukemia. Chemo failed. The doctors told him there was nothing left to do. He was staring down 2 death sentences at the same time. His doctor, a man named Jero Hooder, knew the only shot for the leukemia was a bone marrow transplant. But then, a light bulb went off. A huge one. He thought, what if we don't just find any donor? What if we search for a donor who is not only a perfect match for the transplant, but also has that CCR5 delta 32 mutation? What if we could cure both diseases at the same time? I mean, the odds were astronomical. But they searched, and they found him. A perfect match who also had the mutation. So they went for it. They completely wiped out Timothy's old, failing immune system, the one riddled with cancer and vulnerable to HIV. And they replaced it with a brand new one from the donor. And then, the ultimate test. He stopped all of his HIV drugs. Everyone held their breath. Days turned into weeks, weeks into months. The virus? It was gone. It never came back. So here's how it actually worked. Think of it like completely rebooting a computer. First, you have to wipe the old corrupted hard drive. That's destroying the patient's immune system. Then, you install a brand new operating system. That's the donor stem cells. Those cells get to work building a whole new immune system from the ground up. But this new system, it's better than the original. It's a system built with locked doors. HIV simply can't get in. What Timothy Ray Brown did was more than just survive. He proved that the impossible was in fact possible. He completely changed the game. His cure wasn't just a feel-good story. It was a blueprint, a roadmap for the future. And the most important part, it wasn't a one-off miracle. It wasn't just a lucky break. Since then, the same strategy has been successfully used on other patients. We know it works. The science is solid. The cure is real. And this is what makes his case so absolutely revolutionary. You see, for years we'd known about people whose genes help them control the virus, to keep it at super low levels. But that's not what this was. This was a sterilizing cure. The virus wasn't just being held in check, it was gone, eradicated from his body. So what do we learn from all this? The big takeaway is that a cure for HIV is not science fiction anymore. It's a reality. We learned that the CCR5 doorway is HIV's biggest weakness, its Achilles heel. And by basically borrowing a genetic superpower that already exists in nature, we can beat a virus that we once thought was unbeatable. This whole thing kicked the door wide open for the future of medicine. This one man's story did more than just cure him. It blew open a whole new frontier in science. And it leaves us with a huge, tantalizing question. If we can literally go in and rebuild a person's immune system to defeat a disease like HIV, what's next? What other incurable diseases have a secret doorway we just haven't found yet? What other cures are hiding right there, inside our own DNA, just waiting for us to find them?